Alchemy and astrology are two of the most intriguing topics in the history of science. Part of this is because both of them are now dismissed as pseudosciences, as false systems of belief. But I think it's more than worth our while to take the time to investigate the ways that alchemy and astrology were practiced in the Middle Ages, why they were practiced, and the principles that lay behind the practices. Was there anything rational in alchemy and astrology? Do they belong on the roster of scientific topics? Well, alchemy arrived in the Latin world in the 12th century, along with all those other translations of Arabic source materials. I mentioned to you previously that one Robert of Ketton, sometimes called Robert of Chester, it depends upon how we translate his Latin place of origin. Robert of Ketton translated the first work of Arabic alchemy in 1144, the De Compositione Alchemiae, or the On the Composition of Alchemy. He says in his preface that he did this because the Latins yet knew nothing of alchemy or what it was about. Well, that was probably true to the most part. There is some evidence that there was a little bit of alchemy in Europe beforehand, some knowledge about transmutation of metals, but very, very little. What Arabic alchemy did meet up with in the Latin West was an established craft tradition dealing with some of the same issues. And this craft tradition was summarized in what's often called the recipe literature. These are compilations of recipes, of processes for making stuff, for making glass, for refining metals, for doing metal casting, this sort of thing. The most eminent example of the recipe literature, of craft knowledge, was a book written by a person under the name of Theophilus, probably a monk. The book is entitled De Diversis Artibus, on the diverse arts, and it comes from the first half of the 12th century. It deals with the kind of things that would be carried out in a monastic workshop. So how to make the glass and the leading for stained glass windows, how to make the pigments and the panels for making panel paintings, for making diptychs and triptychs. Well, there was the most significant work then in the early part of alchemy in the Latin West came from the combination of these two traditions, that is, the indigenous craft traditions, the process, the recipe literature, and the material coming in from the Arabic world. And one of the most important syntheses of this, certainly the most important book on Latin alchemy, is the Summa Perfectionis, the Sum of Perfection, written in the 1280s under the name of Geber. Now, Geber, or Geber, depending on how you want to pronounce him, that name should sound a little familiar to you because the author is trying to pass himself off as an Arab. He's trying to pass himself off as Jabir ibn Hayyan. In fact, the text, we now know, was written in Europe. It's a Latin text originally, written probably in southern Italy, and probably by a chap by the name of Paul of Taranto, a Franciscan, a lecturer in a Franciscan school. Well, what does the Summa contain? It contains a detailed summary of the state of knowledge of metals and minerals and details of how to work with them in the laboratory. Now, this includes transmutation. In fact, Geber says that there are 3 kinds of medicines, as he calls them, which are capable of effecting transmutations of different kinds. The medicine of the lowest order, when mixed with a metal and fused with a metal, only colors it superficially to look like gold or silver. So it can't add its qualities deeply, profoundly to the metal, only superficially. Tests and trials on this artificial metal will show that it's not really gold or silver. However, the third order, the highest order of these medicines, is equivalent to the philosopher's stone, that material agent of transmutation sought for by alchemists since the origins of alchemy in Hellenistic Egypt in, say, the 4th century. Well, This third order of medicine really does transmute base metals into gold, into true gold. Now, all of this work in the Summa is in the context of a coherent theory of matter. A coherent theory of matter that's built up of two elements. The first element is the mercury-sulfur theory of Jabir ibn Hayyan and the Arabic alchemists. The sulfur-mercury theory says that all the metals are made out of two components called mercury and sulfur. They combine together in the earth in different proportions, different qualities, and as a result, we get different metals. The second theoretical underpinning is the notion of minima naturalia, which comes ultimately from Aristotle. Now, what in the world are minima naturalia? Literally, it translates into the smallest of natural things. In one place, Aristotle says that you have to have a certain minimum amount of matter in order to hold a form. Anything smaller than that, any quantity of prime matter less than that, simply can't hold a form. So there is a smallest particle of any given substance. This is not really atomism. It sounds a little like it, but it's not, because this is not an idea that matter comes in indivisible particles. It's actually quite different. But Aristotle left this idea undeveloped. The Middle Ages picked up on it. Some medieval writers, like Albert the Great, for example, did link it to atomistic doctrines, to particulate matter theory. And Geber almost does. Now, what's the big deal about this theory? Is it really useful to him? Indeed, it is. He says, first of all, that the metals are produced by the coalescence of minima of mercury and sulfur. In different metals, these minima are in different sizes, in different degrees of packing, whether tightly packed or loosely packed. And in the ignoble metals, that is, the metals that aren't gold or silver, there are some earthy particles, dirt in a sense, mixed in with it. How does this help? Well, it allows him to explain not only physical changes that he sees in the laboratory, but chemical changes and operations of chemistry, chemical processes, explains how they work. Let's look at these three. Take a cube of gold and a cube of tin of exactly the same size and weigh them. You'll find that the cube of gold weighs about 3 times as much as the cube of tin. It's the denser metal, is the way we would say this. How is this explained? Well, Geber says that the particles that make up the gold are the very smallest minima of mercury and sulfur. So they pack together very, very tightly. There's very little pores or empty space left between the particles. Tin, on the other hand, is made up of larger particles, and there are those earthy particles mixed in with it. So it's a looser contexture. There's more empty space. There's less matter. And so, naturally, tin is less dense. There's less matter per unit volume. So there's a physical explanation. How about chemical explanations? Well, if we take gold and we put it in a fire, nothing happens. It's not burned up. It's not damaged. It comes out of the fire just fine. We drop it in acids. It's not attacked by corrosives. Or by boiling it up with salt or various other kinds of corrosives. If we take gold, put it in the ground, it'll come out 1,000 years later just as bright and shiny as the day it went in. Other metals aren't like this. If we put lead in a fire, it falls apart into a powder. If we bury it in the ground or just leave it exposed to the air, it tarnishes and corrodes. Well, again, Geber explains this using his coherent theory. The packing of those particles in gold is so tight, there are no pores, there are no openings for corrosives to get in and tear the structure of the gold apart. On the other hand, lead, being loosely packed, made up of big particles, leaves a lot of pores that corrosives can get in and reduce it to a powder, or fire reduces it to a powder as well. How about chemical processes? Let's take sublimation. In sublimation, we take a substance, put it in a sublimatory flask, and heat it up. The solid material vaporizes. Those vapors rise up into the cooler parts of the flask where they condense out again into a purified solid. Geber explains this, again, based on particle sizes, that the smaller particles are lighter, they're driven up by the fire more easily, whereas the gross, heavy particles stay at the bottom. So he's got a workable theory here that seems to be able to explain quite a lot of things. Well, many other alchemical texts appeared in the 13th century. The two characters I talked about previously, both Roger Bacon and St. Albert, touch on these issues. Albert wrote on minerals. There's also a little book on alchemy which is attributed to him, which is similar to the Summa Perfectionis of Geber, but is even more practical in terms of how to make things in the laboratory, even closer to sort of craft traditions. Roger Bacon insists upon the importance of alchemy because alchemy has great power over nature. What does he mean by this? He says that not only is alchemical gold as good as natural gold, it's better. It's better than natural gold. Now, this is a powerful statement about the power of human artifice, about, in short, technology, the ability of human beings to exceed what nature can do. It flies in the face of Aristotle, who said that art can only complete what nature fails to finish, or art can only mimic nature, and that artificial and natural things are inherently different. For Bacon, yeah, artificial things and natural things are different. Aristotle's right there. Bacon says the artificial ones are better. Think about what that means in terms of setting the foundations for the technology that we take for granted in the modern world. It says a lot about how we interact with the world and how we outdo it, how we improve upon it. Well, if we move on to the 14th century from the 13th, we find that just as many alchemical works are being published, but they become more secretive suddenly. They start using imagery and parable and metaphor and allusion rather than clear operational language. Why? What happens? Well, there are probably a number of reasons, not all of which we're aware of at this point. It's still partially an unsolved question. But there are a few things that lead into this. First of all, the Summa Perfectionis of Geber is written most of the way through in a very clear scholastic style, the kind of thing you would expect for a Franciscan lecturer to do. But the first chapter and the last chapter seem somewhat out of place. There he talks about secrecy, about reading sort of between the lines of what he said. He uses an initiatic style as if he is a great sage initiating acolytes into mysteries. It doesn't fit with the rest of the text. Where's he getting this from? Well, remember, he's trying to pass himself off as an Arab. In fact, he writes his Latin sometimes in rather contorted ways, so it looks like a translation out of Arabic, using Arabic grammatical structures. What he also does is he picks up this style from the real writings of Jabir ibn Hayyan and sort of sticks them on as bookends to the whole text. Now, the odd thing here is that it's out of place for the scholastic style of the Summa, but it's perfectly in keeping with the original writings of Jabir ibn Hayyan. Remember, they came out of an esoteric Ismaili sect, a Shiite sect of Islam, where this kind of style made sense. Well, there are probably some other reasons. Alchemy has to go a little bit underground because legal and moral objections against it start to surface. In 1317, Pope John the 22nd passes a bull outlawing transmutation. Why? Well, think about it. If you can make gold and your economy is based on gold, then a successful alchemist would successfully subvert the entire social, political, economic order of the state. So we have to be very careful about guys who go around saying they can make gold. There are also moral problems. Is artificial gold the same as natural gold? If it's not, then is it moral to sell it as if it were gold? If it's just a cheap look-alike, there's the danger that it could be sold to the mint mint it into coins, and you'd get a debased currency. Again, economic problems. Well, there's still a lot to understand about alchemical imagery, but it very rapidly becomes almost incomprehensible. That is, substances, rather than being named openly, get named by what are called decknamen, or cover names, code names, secret names. Rather than mentioning chemical operations like distillation and sublimation openly, these operations are woven into allegorical narratives. Now, since the major source of imagery, the major source of art in the Middle Ages was religion and theology, images from theological truths, Christian truths, play a particularly important role in alchemy. There's some clear examples why this would be good. The philosopher's stone changes base metals into perfect ones. Well, Christ, by his vicarious sacrifice, turns sinful men into redeemed men. So there's a relationship there clearly between what the philosopher's stone does to metals and what Christ does by his vicarious sacrifice. Moreover, terms like death and resurrection and exaltation and glorification get used in alchemical texts to hide the real meaning. Now, I should mention just quickly in passing that much later on, in fact, in the 19th century, so some 500 or 600 years after the period we're talking about now, an interpretation was suggested of alchemy that alchemy was largely a religious or a spiritual endeavor, that it dealt with changing the soul, the spiritual state of the practitioner. This, again, is a 19th century retrospective reading of alchemy. There's really very little evidence of this kind of a reading of alchemy, this kind of deployment of alchemy in the Middle Ages. There's no question that the alchemists were devout religious people, but there's no sense in their writings that what they're engaging in is some kind of self-psychic or spiritually altering endeavor. Now, alchemy in the 14th century was also extended to medicine. One particular person bears much of the credit for this, John of Rupiskissa, a Provençal Franciscan. He promoted the production of what he called quintessences, that is, the refined essences of metals and minerals. He used newly discovered substances to do this. The mineral acids, nitric, hydrochloric, sulfuric acids, to dissolve the metals, and then alcohol distilled from wine for about the first time in this period for extracting the finest essences of this. Well, he too spent most of his life in prison, rather like Bacon. Rupiskissa spent much more time in prison. This is because Rupiskissa was an unabashed spiritualist Franciscan, one of these prophetic people looking for the coming of the Antichrist. And this is one reason he was so interested in alchemy. It gives us wealth, it gives us health. They would be tools, resources needed by Christianity to fight the Antichrist. Well, alchemy continues to develop down until the end of the 17th century, and we'll pick up alchemy in its later phases in a later lecture. Now, let's turn to astrology. Now, astrology and astronomy were very closely linked throughout the Middle Ages in both Latin and Arabic cultures. We're going to deal with issues concerning cosmology, that is, how the planets move, in the next lecture. Right now, we're just going to talk about astrology, the calculation of the positions of planets and their effects on Earth. Now, these two, that is, physical astronomy and positional astronomy, were generally pursued by the same people. Classic example is Ptolemy, who writes both the Almagest that talks about how the planets move and the Tetrabiblos that tries to figure out what the effects of those motions, of those positions, will be on Earth. What we have to remember is that more people were interested in getting the planetary positions right for astrological purposes than rationalizing a mechanical, physical method of how the planets got to those positions. Now, how do you figure out the position of a planet in the sky, either in the past or in the future? Well, to do this, one uses tables. Tables to make predictions, to make calculations. Tables of positions of planets go back to Babylonia. Babylonians were very interested in astrological positions, or astrological predictions. Tables became much more highly developed, actually, in the Islamic world. They were called zij in the Islamic world, these tables. And they came to Europe along with the translation movement, the first being the table of Al-Khwarizmi, put together in the 9th century, translated by Adelard of Bath in 1126. Robert of Chester, or Ketton, depending on what we want to call him, made up his own tables, and in the middle of the 12th century, many, many new tables came into existence for various places, in Pisa, in London, all over Europe, using often old Islamic tables and updating them. The most important set of tables, however, were the Alphonsine tables, which were put together around 1275. They get their name because they were dedicated to King Alfonso X of Castile, sometimes called El Sabio, the wise one, or the learned one. So you would use these tables. They would give you numbers that you could add up and get the angles, the positions of the planets, where in the zodiac they would be. Well, this interest in positional astronomy was geared towards astrological purposes. Now, astrology contains within itself several different subsets, and these different subsets got differing receptions. The most common way we think about astrology today has to do with the fates of individuals, that is, prognostications of human destinies, of human futures. This part of astrology was clearly and repeatedly condemned by the Church, early on, in the Middle Ages, and many times in between. The condemnation of 1277 explicitly condemned the notion that the stars control our destinies. Why is this such a problem? Well, of course, that would infringe upon free will, which in the Christian faith is one of the greatest gifts that God gives to man. The stars do not control us or our fates. We control our own fates through free will. Much more acceptable now within astrology is the notion that the planets have some kind of influence upon the Earth. And this influence can be explained in many, many ways. And there are many, many examples of this kind of influence. Let's just look at the obvious ones if you don't believe me that astrology is something worth pursuing. We know that the tides of the ocean are caused by the moon. So clearly there's a celestial body that has a tremendous impact on the Earth. The seasons, warm in the summer, cold in the winter, are produced by the position of the sun in the zodiac. Another clear example. The compass needle, points towards the north celestial pole by some unknown power. So clearly there are influences streaming down from the heavens onto the Earth. The question is, what do they do when they get here, and how do they operate? Well, there are lots of different explanations of that. At the beginning of all this, Ptolemy in the Tetrabiblos uses the qualities of the planets to explain their activity. For example, the planet Mars is hot and dry. Therefore, at certain positions, it can extend the qualities of hotness and dryness down to the Earth. Similarly, the moon is cold and wet. It must be cold and wet because it affects water, which is cold and wet. Now, what effect would these influxes have? Well, they're not always the same. The kind of effect depends upon where in the zodiac the planet is, what its angle is with other planets, for example. Let's look at medieval medicine, where astrological thinking was particularly important. Medieval medicine was based on the humoral theory of Galen. That is, that we want to have temperament in the body that is a harmonious mixture of qualities. The four humors, blood, phlegm, black bile, and yellow bile, have qualities themselves. Too much blood and we get too hot. For example, get a fever. Well, the position of a planet and the influence of its rays might upset this balance and cause sickness. So looking at astrological positions can help a physician diagnose the cause of an illness and prescribe an herb to counteract it. A particularly bad combination of planets could affect the air and the human constitutions so much that a plague would erupt. So naturally, when the Black Plague breaks out in the middle of the 14th century in Europe, there's even more interest in finding astrological explanations for it, astrological ways of dealing with the plague. Now, there's also birth horoscopy, and this is extremely important. You need to know the exact time at which a child was born, the idea being that the child at the moment of birth is imprinted with a certain physical constitution based upon the influences that child receives from the prevailing astrological, astronomical conditions, by prevailing celestial influences. Once we know this, we can figure out, for example, for that child's future, how he might be susceptible to particular diseases. There would be a particular complexion, a physical complexion imprinted, so it would tell us a little bit more about future disease. It could also warn us about the child's potential or susceptibility for certain character traits or character flaws or tendencies. In a sense, we're trying to do that now still, except by a different way. With DNA, we try to find out susceptibility for future susceptibilities to diseases or character traits. The medievals used astrology for this. Whether one is better than the other maybe is still open to question. Also, the medievals here addressed an issue that again is important in the modern era. That is, the importance of nature versus nurture in a person's personality. How much of our personality is determined by our genes, by our nature, by our physical makeup, how much by our environment. The medievals also tried to negotiate this boundary between how much of a person's actions, activities, and tendencies are dependent upon free will and choices and their environment, and how much upon the imprinting by the stars, the influence of the celestial bodies. The curious thing that I should point out in passing about this is that the modern nature-nurture question has all but eliminated the one essential characteristic that was most important to the medievals, and that is the exercise of free will, of choice. Now, one might ask, why did so many people believe in astrology? Why wasn't it refuted sooner? Well, we can already see that there were clear evidences of astrology every day in the tides and the seasons, for example. But moreover, there are some social reasons that help to undergird astrology. The medievals lived in a very uncertain world. We have a hard time understanding how uncertain their world was. Death was all around them. Sickness came at any hour and from causes that they had no knowledge of. So, in a sense, astrology is one way to get a warning about potential dangers, to be on the lookout for problems that could arise, to help give you some kind of power in a world in which you are largely powerless against your environment. Ptolemy, moreover, said that the system is very complex. It's really easy, says Ptolemy, to figure out where a planet's going to be. It's very hard, however, to figure out what that position is going to mean. And in this sense, if we're asking the question of why astrology wasn't refuted earlier in history, we have to realize that the system is very complex. And whenever we're dealing with very complex systems, the failure of predictions or the occasional success of predictions doesn't usually do very much to validate or invalidate the art. For example, weathermen can give wrong prognostications of the weather very frequently, but we don't give up on meteorology. We just say, well, it's an extremely complicated system. On the larger scale, climatology deals with an incredibly complex set of factors dealing with world climate. Well, it's easy to measure temperatures. It's easy to measure rainfall. It's easy to measure wind. But what does it all mean? Is there global warming or not? Well, it's a hard question to answer, partially because the system is so complex. Well, and finally, speaking of prognostications, we might match this to economic theory. It's easy to measure unemployment. It's easy to see what the stock market's doing on any particular day, but trying to predict in the future what the economy is going to do a year from now is very hard and tricky. Yet, we still give out Nobel Prizes to economists, realizing that the system is very complicated and very difficult. So to sum up, we've seen in this lecture how alchemy and astrology, now I think too easily dismissed as pseudosciences, were closely related, indeed almost inseparable, from what we might now call chemistry and astronomy in the Middle Ages. They were serious pursuits in the pre-modern period, and their practitioners had good reasons for their practices. In our next lecture, we're going to continue looking at specific medieval contributions, this case in the physics of motion in the heavens and on the earth.